All right, you guys, we're starting out with lesson 10.1 for unit 10. Learning target today is to write arithmetic sequences both recursively and with an explicit formula. And we'll kind of go through all those vocab words as we get started, okay? So first thing is, what is the next number in this sequence? We have 26, 39, 52, 65, and 78. Well, in order to find out what the next number is, you have to figure out what that pattern is, right? So we're going to go through and talk about what a sequence is and then how we get there, okay? So a sequence is an ordered list of numbers that often forms a pattern. Each number in that list is a term of the sequence. Okay, so we call each number in the list a term. In an arithmetic sequence, the difference between any two consecutive terms is a constant called the common difference. And we call it the difference because we subtract to be able to find what the difference is between the two numbers, okay? Arithmetic means that we're going to either add or subtract to get to the next number. So if I go back up here to my sequence that we repeated down here, you can see if you take 78 minus 65, you get 13. 65 minus 52, 13, and so forth. Okay, 39 minus 26 gives you 13. So the common difference of 13 in this pattern, so there is an arithmetic sequence. You can think of a sequence as a function or even an equation, right? Where the domain is restricted to the natural numbers and the range is the terms of the sequence. Okay? So, kind of getting into the little bit more of the equation and what they mean, okay? For the sequence 26, 39, 52, 65, and 78, okay? Let n equal the term number. Okay, so if I were to draw a little chart, right? This would be term 1, this is term 2, term 3, term 4, and term 5. Okay? Let a sub n equal the value of the nth term of the sequence. So like we say here, a sub 1 is the first term, right? That 1 means the first term, and that first term's value is 26. So if I go back up here, term 1 is 26. A sub 2 means the second term, so this 2 is the second term, and the actual value of that term is 39. Okay? We use subscripts. Subscripts are these little numbers here, right? When it drops down, the opposite would be like an exponent that's a superscript. Okay. And subscripts kind of tell us what term we're talking about in the sequence. Okay. So how is this arithmetic sequence similar to a linear equation? And we're going to talk about that here. The common difference is kind of like slope, right? Common difference. Oops. Hang on here. Okay, not sure what happened there. But the common difference is just like slope. So we're going to see even more similarity here as we move forward. Okay, so the two different types of formulas that we're going to talk about with arithmetic are recursive and explicit. Okay, one is more helpful than other in my opinion, but recursive in math means to repeat a process over and over again, okay, using the output of each step as the next input. Okay, so a recursive formula relates each term of a sequence to the previous term. it is composed of an initial value, so the starting amount, and a rule for generating the sequence. Okay, so the biggest thing about recursive is when I teach kids this, I always say it's not very helpful. And here's why. Recursive means repetitive, and it goes based off of what you previously knew, which means that you have to know the previous term to get the next term. Okay. So if I know the first term, right, and I want to know the 52nd term in the sequence, I would have to go all the way to the 51st term to get the 52nd one. So it's a lot of work and it's not overly helpful. Okay. So let's go through what this formula is. All right. So the recursive formula, again, this is the recursive one. Okay. We have to have two things for all of our formulas, which is the first term in the sequence. Okay. And then that common difference that we talked about. What are they adding or subtracting by every single time? Okay. Then for this one, since it's not very helpful, you also have to have the previous term. So like I said, if you want the 52nd term, you have to have the 51st term. Okay. So, and then n would be whatever term we're looking for. Okay. So a recursive formula describes the pattern of a sequence and can be used to find the next term in a sequence. Just the next one. All right. And you're going to see what it looks like here as we get this next problem. So, what is the recursive formula for the height above the ground of the nth step in the pyramid shown? Each step is 26 centimeters tall. So, again, we need a sub 1 every time, right? And we need the common difference every time we write a formula. So, each step is 26. That means I'm adding 26 every time. That's our difference. And then if each step is 26, that means this first step down here on the bottom is 26 as well. Okay. So if I go back up to my formula from above, we start with a sub n, right? So a sub n equals a sub n minus 1, so the term before it, and I'm going to add 26 every time. Then I'm going to tell you that my first term has to be 26 to get started. Now that's just for this one because it's just the steps. Okay. So then, like I said earlier, it says use the recursive formula to find the height above the third step. Well, if you want the third, you have to have the second. Okay. So if we look here, we'll have to do the second step first. All right. So we would do a sub 1 again equals 26. And we would have a sub 2 equals the one before it, which is 26, plus another 26. So then a sub 2, or our second step, is 52 centimeters tall. Right? So then if I want to do the third step, same thing. I have to do a sub 2, right, to know which one was before it, which was 52. And then for a sub 3, our third step, I would have to do the one before it, which is 52 centimeters tall, plus another 26 centimeters. So our third step would be 78 centimeters tall. Okay. So again, one before it, a sub n minus 1, so you're going back one from the one you have, and then add on the common difference of whatever it is that they are adding or subtracting by. Okay. Now, an explicit formula is the one that is the helpful one. We can find whatever term we want without having to know the one previous. So an explicit formula expresses the nth term of a sequence in terms of n. So the explicit formula for an arithmetic sequence, again, explicit for arithmetic, okay, looks like this. A sub 1, so you still have to have your first term, plus n minus 1, the term number is your n, so I want the 52nd term, I would put 52 in there, times the common difference. Okay, that d is your common difference. So If we're multiplying by the common difference, that means we're going to get there quicker, right? So we don't have to keep adding, then adding, then adding again. Okay? So let's use that to help us with this next part. The cost of renting a bicycle is given in the table. How can you represent the rental cost using an explicit formula? Okay, well, first thing you have to have is a sub 1 and your d, right? Every time. So my first term is 26, and then to get the common difference, we're going to subtract from the back to the front every time. When you subtract, you get 12 here, 12 again, and 12 here. So my common difference is 12. And then I'm going to plug it into my formula. So we're going to go back up here and write down what we got. A sub n, right, because I don't know what term I want yet, equals a sub 1, and we said that was 26, plus the term before it, n minus 1, times d, our common difference, which is 12. Okay? And then you can simplify this a little bit more if you wanted to by doing 26, and then we'll distribute the 12, so 12n minus 12, and then combine like terms. So our final one would be a sub n equals 14 plus 12n. Okay? So then if you drop down here, it says, what is the cost of renting the bicycle for 10 days? And remember, days is your term number. So I'm going to plug 10 in here for n. So a sub 10, the 10th day, would be 14 plus 12 times 10. So 14 plus 120 means that if I wanted to rent the bike for 10 days, it would cost me $134. Okay? So how is the explicit formula of an arithmetic sequence related to the linear function? Well, if you kind of looked, we had explicit here, right? And we had a sub n equals 14 plus 12n, right? Well, hopefully that is reminding you of our linear equation, which looks like this: y equals mx plus b, right? So this m and 12 would be the same for slope, and 14 and b would be our amount, right? So common difference equals 12. And on here, your slope would be 12. So those are the same type of thing. And this is your initial value or your starting amount is when n equals 1 for that first term. And your initial value here is when x equals 0. That's when we start. Okay? So they're almost identical to each other. Okay, so using that, if I said the cost to rent a bike is $28 for the first day plus $2 for each day after that, right? You're thinking in your head right now, this is exactly the type of thing that we learned when we were first starting our work together in Algebra 1, like way back in like August and September. So if I say the cost to rent a bike is $28 for the first day, that'd be like your B, right? So plus 28, and then plus $2 for each day. That's like your X, your slope. So if we go back and write an explicit formula for this, it would be A sub n equals the first term, 28, plus our n minus 1 times $2 a day. Okay? Now, if I want to know the cost for running it for 8 days, then 8 goes in for n. So I would have A sub n, or 8, I'm sorry, equals 28 plus n, which is 8, minus 1 times 2. So I have 28 plus 7 times 2. So A sub 8 equals 44. Or 42, sorry. Okay? All right. Now, what we're going to try to do here is flip back and forth from writing a recursive to an explicit formula, and then vice versa. Okay? Okay, so to write an explicit formula from a recursive formula, we still have to have the two things we talked about from the very beginning, right? So it says the recursive formula for the height above the ground of the nth step of the stairs shown is a sub n equals a sub n minus 1, the one before it, right, plus 4, because every step is 4 inches tall, with a sub 1 equaling 7. What explicit formula finds the height above the ground of the nth step? So this one, again, is the one that's not very helpful. It'll only give us the next one. So if I wanted to know like the 87th step, that would be a lot of work. So we want to write an explicit formula to be helpful. So we always need a sub 1, which they gave us, 7, and we always need d, the common difference, which is 4. Okay? So to write an explicit formula, we start with a sub n, okay? Then we always start with that first term, which is 7, plus n minus 1 times our difference, because we want to get there faster, right? So then again, if you would like to distribute this, you can have 7 plus 4n minus 4, combine like terms, and we would have 3 plus 4n. And this would give us whatever term we wanted to have. Okay? Take a minute and go ahead and try the next two by yourself, and then pause the video and check and see if you got it right. Okay, so same thing. You have a sub 1 equals 10. Your common difference here is going to be negative 3. So we're going to start with a sub n equals my first term plus n minus 1 times my difference. Then distribute a sub n equals 10 minus 3n plus 3, because this is a negative times a negative, right? So I have a sub n equals 13 plus negative 3n, or just minus 3n, whatever you want to put there. Okay. Same thing over here. A sub 1 equals negative 1. Your common difference is 2.4. Okay. So then a sub n equals your first term, negative 1, plus n minus 1 times your common difference. So again, if we distribute, we have negative 1 plus 2.4n minus 2.4. Okay, combine like terms, and a sub n equals negative 3.4 plus 2.4n. Okay, now flip that around. Write a recursive from an explicit. Now, the thing you have to remember here is you still need those two things that we just talked about, a sub 1, and you need your common difference, right? Now, your common difference is going to be given to you. That's what you're multiplying by every time, right? So this is 1/2. But your first term, remember, this has been multiplied, and then these were the combined like terms. But the good thing is that in your explicit formula, you can find whatever term you want. Well, we need the first term, right? So we're going to have to go in here and plug in a 1 for n to find our first term. So if I use this one, a sub 1 equals 1 plus 1/2 times 1, because I want the first term. I need it. I got to have it for my recursive formula. So I solve this. A sub 1 equals 1 plus, and then these two together is just 1/2. And then add them together, and we get 1/2. So the first term in my sequence is 1/2. Now I can write my recursive formula. I start with a sub n, then I start with the first term, 1/2, back that up. Sorry. I got ahead of myself. That goes at the end. A sub n. Then I start with the previous term, a sub n minus 1, right? Plus my common difference, 1/2. Okay? Then I have to tell where I'm starting from. So my first term is 1/2. This is just a semicolon. It's just part of the, not part of the actual equation. Okay? It's just separating those two things. All right, let's try it again since I kind of screwed that one up for you. So again, if I'm writing a recursive, I still have to have a sub 1 and my common difference, right? So again, I don't know my first term because it's been multiplied in here, right? And then combined like terms. So I'm going to find it using this. So a sub 1 from this term, 8 plus 3 times 1. What was my first term? So a sub 1 equals 8 plus 3, which means my first term was 11. Okay, common difference is what you're multiplying by. So that's going to be 3. And then we're going to write our equation. So I have a sub n equals the term before it. So a sub n minus 1 plus my common difference, which was 3, and where I'm starting from, which was my first term of 11. Okay, one more. Same thing, you need a sub 1 and you need d. Okay, a sub 1 we don't have because it's been combined, so let's go get it. 12 plus 5 times 1, that's our first term, gives me 17. So a sub 1 equals 17. My common difference is what I'm multiplying by, and I'm going to write it out. Whatever term you want, you got to start with the one before it, and minus 1, add your common difference of 5, and then where are you starting from? The first term is 17. Okay? Good job.